All right, so here's another think, pair, share problem. So once again, try and complete this problem on your own and use this video to help you kind of progress through it if you get stuck. So let's just dive right into it. You'll notice that the data set looks similar. I try to use the same data set. So if you compare one example with this data set with another example which uses the same data set, but maybe one little value is different, it'll help you compare the two and see what difference that little change made to the problem at large. So that's kind of the reason why I keep using the same data set. Okay. A random sample of 11 statistics students produced the following data, where X is the third exam score, let's see, of 80, and Y is the final exam score out of 200. Use a 97.5% confidence level to determine if the sample line of regression models the population. Assume no outliers exist. So, here's our list of X values. Here's our list of Y values. And we're going to work through the following four questions. Does there appear to be a linear trend between both variables? Now I have hand sketch a scatter plot, but in the interest of time here, I'm going to use the calculator to do that. What is the literal strength of the line of regression? Does the line of regression estimate the sample data with at least a 97.5% confidence level? And does the sample line of regression model the population line of regression with a 97.5% confidence level? All right, so let's kind of dive right into this. So question one is there a linear trend? Okay, so what we need to do is consider this first column to be our X values and the second column to be our Y values. And we want to plot this. So what I did is I went ahead and entered the values into the Texas Instruments and the NumWorks calculator. I'm going to go ahead and show this on the NumWorks first. So you want to go to the regression app, put in the list of X values and the list of Y values. And let's just pop on over here to the graph tab and click OK. All right, so this is left over from the previous example where I set what the X and Y values were, and you can see we don't see anything. So what I need to do really quickly is come up to this auto and click OK. And so it'll auto set the range of X values and the range of Y values to include our data. All right. So as soon as I hit auto and I turn that on, you can see now it's orange. Now we see the data. The other thing that it has done is it's gone ahead and done the line of regression. So that might have been, you can see this line right here. That might have been a carryover from the previous example. Let me see. Let's see here. Let me see if I can turn that off. Let's see here. If I go to regression, okay, it gives me that stuff. Yeah, let me put remove regression here. Okay, so here's the scatter plot all by itself shown here. All right. And it does look like there's a linear trend. Okay, it does look like there is a linear trend. Let's go to the Texas Instruments. And you want to go to the list editor, put in your list of X values, your list of Y values. Let's first go into Y equals to make sure we don't have anything left over, which I do. So I'm going to hit clear to clear that out. Now let's go to the statistical plot. So I'm going to hit second and Y equals. Make sure the other plots are off. So plot one is on, which is fine. If it was off, I would turn it on. And under type, we want to make sure that we choose the scatter plot type, which is this first icon here. So you would put your cursor on it and hit enter, and that would select it. The list of X values you can see are in list one. And the list of Y values are in list 2. And, I'll choose that mark. Okay, that's all fine. Now, if we want to see it, we want to hit zoom, go down to zoom stat, and hit enter. Okay, there we go. Now, in this one, we're being told to assume that there's no outliers. Okay, this point here looks like it could be an outlier, right? Because all these points appear to be going up and to the right, and this one's really kind of outside of that. You can see that same point here. It's actually highlighted. It's the point 65, 175. Let me see here. If I choose, if I move up and down these points, it's the point 65, 175. If I want to do the same thing on Texas Instruments, I can hit the trace button. And now I can go to each of these different data points. But the first one here is the one which is 65, 175. That one could be an outlier, but that's for the next section. We're not going to worry about that. But anyway, this question is, does there appear to be a linear trend? So you'd want to try and sketch this by hand if you could. But what I'm going to do here is I'm just going to do like a quick sketch to show that the points appear to be going up and to the right, something like that. And I'm going to put that one point up there and kind of draw a line of regression. So the answer here is going to be, so the answer to this first question is going to be yes. There does appear to be a linear trend to the data. Let's see. And so the other thing we can note here is that because our slope is positive, so we have a positive slope. So because we've got a positive slope, oh my goodness. All right, because we have a positive slope, that implies that we're going to have a positive correlation coefficient when we get to it. Okay. And, okay, I've drawn that sketch there. But when we look at the actual scatter plot itself, there is some more scatter around these points or around this line of regression, around the linear trend. So we can expect the correlation coefficient to not be close to 1, but also not close to 0. Um, just by experience, I would say maybe around 0.7, perhaps. I'm just going to kind of guess. So, I would say that maybe our correlation coefficient is maybe like around 0.7. Okay. But again, this is just kind of a guess. But it's okay to put down nonetheless. The other thing we want to come up with is to calculate our mean point, which is X bar, Y bar. So let's do that really quick for both calculators. So Texas Instruments, we want to run two variable stats. So stat, calc menu, second option down, two variable stats. Okay, list 1 and list 2, that looks good. Hit calculate. So we have X bar is 69.18 and Y bar is 160.45. So we have 69.18, 160.45. All right, on the NumWorks calculator. So on the NumWorks calculator, we want to go to the Stats tab. And that'll give us the mean for each column. So you can see we get 69.18 and 160.45. All right. So, question one was, does there appear to be a linear trend between both variables? And the answer is yes, there does appear to be a linear trend to both variables. It's going up and to the right. It'll have a positive slope. Um, as x increases, y increases. Okay, x is increasing in a positive direction, y is increasing in a positive direction as well. All right, so let's move on to question two. We'll do that on the next page. All right, question two is, what is the linear strength of the correlation? So what we need is we need our correlation coefficient, and we also need the literal translation table. All right, so to get the correlation coefficient on the Texas Instruments, we're going to use ln-reg AX plus B. And on the NumWorks, we're going to use the regression option in the graph tab. So let's do the NumWorks first to kind of change things up. So we're going to go to the graph tab here. Now again, this might be left over. No, okay. So here's the regression option. So I'm going to go up. Let's see, because right now a point is selected. So if I click up, it's going to put me into these options here on the top. I want to go to the regression option, click OK. I want to do a linear trend. There it's giving me X bar, Y bar. And if I click up once, or is it down? I always get that wrong. Here's the line of regression, okay, but we want the correlation coefficient. So let's go to the stats tab now. So I'll click up, go to the stats tab, click OK, scroll down till we get the correlation coefficient R, which is 0.663. Okay, so R, it's going to be 0.663. And let me go ahead and write what our line of regression equation was. Let's go back. Now we can get it from this screen too. If I scroll down, here's our linear model. And here it's giving us the slope, okay, the value for M. And this value here is the value for B. All right. So I'm going to write this out to 3 decimal places for both numbers. So that's going to be 4.827x minus 173.513. So that's going to be the equation for my line of regression. So now let's get this on the Texas Instruments calculator. So I want to go to Stat, hit the Stat button, go to Tests. Oh no, Calculate, sorry. Calculate menu. Go down to number 4, which is ln-reg. Click Enter. Okay, list 1, list 2, and I'm going to graph this. So I'm going to store this in one of the y variables. For when we hit y equals, it'll put the equation there for us. So let's go to the variables button. Go to y variables menu. We want function. And let's put it down on y4 this time, just to kind of change things up. And we'll hit calculate. Okay, and there's the slope, 4.827. And there's the y-intercept, which is negative 173.513. and our correlation coefficient of 0.663. All right, and if we want to look at it, let's first go to y equals. Okay, there's the equation in variable y4. And the reason why I put it in y4 is because I wanted it to be in a different color than blue. I could have chosen red or black, but it's going to be magenta. So I'm just going to hit the graph button, and there it's plotting it in magenta. Okay. And you can see now with the line of regression plotted in here, you can see that how this point could be an outlier because all the other points appear to be, a little bit more tightly bound to this line of regression, except this one seems to be pretty far away, right? This one too, but not nearly as much as this one. And this point, which could be an outlier, also could be tilting this line of regression up towards it. You can kind of see that maybe without this point, this line of regression wouldn't be here. It would actually be a little bit lower and maybe go up like that. Okay, but we'll look at that here in a future section. I'm just kind of giving you a heads up. All right, so we ended up getting the same correlation coefficient and line of regression equation for both calculators. Let's look this up. So we have 0.663. So here's the literal translation table, and if we look for 0.663, it's going to be right here. 0.663 is between 0.6 and 0.799, which is going to make this a strong correlation. Okay, that's the literal description of our correlation coefficient, is that it's strong. So I'm going to come back to our example here. So our value of the correlation coefficient is less than 0.799, but greater than 0.60. So this implies that we've got a strong correlation. And that was the point of this question, was just to kind of literally explain the strength of our correlation coefficient. It's strong. All right, let's go ahead and move on to question 3. So question 3 is, does the line of regression estimate the sample data with a 97.5% confidence level? So what we're going to do here is we are going to end up comparing the correlation coefficient of our sample to the correlation coefficient critical value. And we just figured out that the correlation coefficient of our sample, or our SAMP, is 0.663. So this is what we need. And not only that, we also need, sorry about that, we also need to draw our little illustration. So this is going to be our number line for correlation coefficient values, which will span between -1 and +1, and we'll put 0 in the center. And we're going to have two boundaries. One boundary is our positive R critical value, and the other boundary is our negative R critical value. Between the two critical values is the region, which we would consider to be a bad estimator of the data, and both above and below these critical values are what we would consider to be a good, the region to be a good estimator of the data. So we know that our sample correlation coefficient So our SAMP equals 0.663. Well, we need to figure out which side of these boundaries this value is actually going to be. So how do we get this critical value? So for that, we need to use some custom programs. There we go. So first with NumWorks. So NumWorks, I can't put programs on it, but I provided the program for you here. So if you're looking at the PDF um, of these lecture notes, you should be able to click on this link, and it's going to open up a web page. And so it might be a good idea when it brings this up as a tab on your web browser to bookmark it, so that maybe you can more easily come back to it when you need it. Okay, bookmark it. So let's go ahead and do that. So here I'm in a web browser. That's kind of what I'm using the NumWorks calculator in. And so here is the R critical value calculator. It's using values left over from the previous example. So I'm just going to click try a similar question. It makes that go away. All right. So I think we had a sample size of 11. All right. So I'm going to type in 11 here. Oh, and so what's going to be the significance level? So let's come back. All right. So we have a sample size of 11, and we have a confidence level of 0.975, which means we're going to have a significance level of 0.025, right? Because if we add those two up, they should both add up to 1. All right, so this significance level is what I'm going to enter in here, 0.025. So I'm going to put 0.025 and hit submit, and I get 0.6669. Okay. I'm going to round that to 0.667, so 3 decimal places there. All right, so we get an R crit value of 0.667. So here we're going to have a positive 0.667. We're going to have a negative 0.667. And look at that. This critical correlation coefficient for our sample of 0.663 comes just underneath, just a little less than our critical value. So our line of regression correlation is actually considered a bad estimator of our data. It just comes in underneath. All right. Let's see how we calculate this with the Texas Instruments. So click on Programs, go down to R critical value, and enter twice. So we have a sample size of 11 and a significance level that says alpha. Okay, that's the Greek letter for that represents significance level. And I'm going to put 0.025, and you want to put two-tailed here. And we get 0.667. Okay, same value that we just got. All right. So, at this point, you would typically go ahead and you would stop your linear regression analysis at this point. Okay, because it's just not a good estimator of the data. We can't use it to do any predictions. Okay, but we are going to go ahead just so that you get some practice with answering the last question, which is question 4. And basically what we're looking at is we're looking to find if the slope for the sample line of regression, if the slope for the sample line of regression is significantly different than 0. Okay, we want to see if it's significantly different from 0. So what we need to do is we need to create a confidence interval. Okay, so what we need is we need to create a confidence interval around the slope of our line of regression and see if 0 is in the interval. All right. So if we're going to do that with the numworks calculator, then what we need to do is go back home and we want to run the inference app. Go to intervals. We want to create an interval around slope. Okay, and this is where you get to choose the data. Okay, if I'd put data in these other columns, I could choose it here, but I didn't. So this is the data I'm working with. And remember, you have to scroll down past the last row to see the prompts for moving on. Now our confidence level is different. So here our confidence level is 0.975 or 97.5%. Don't just zoom past that. Okay, you got to make sure you change it if it needs to be changed. And we'll hit next. Okay, so here it's giving us the slope for our line of regression. And here it's giving us a margin of error around that slope. Let's scroll down to next. All right, and this is giving us our confidence interval. So notice that the lower bound is negative and the upper bound is positive. So we get negative 0.0499, and here we get a positive 9.705. So let me go ahead and write that down. So the slope that we calculate, so the confidence interval is negative 0.0499 to a positive 9.7047. Okay, now if we, graph this on a number line and we put 0 here in the middle, okay, the lower bound of our interval is negative, so that's going to be to the left here. So we have negative 0.0499. Our other value is positive, so that's going to be to the right of 0, and that's a positive 9.7047. And so you can see that between our lower bound, oh, come on. Apologize for my computer acting a little slow. So between our lower bound and our upper bound, 0 is included. So that means the slope of our line of regression is not significantly different from 0 because 0 is in this interval around our slope of the line of regression. Okay, so we would write the sample line of regression does not model the population significantly different from 0, meaning there is no correlation and write that as an answer. Okay, but let me show how to do this on the um, NumWorks calculator. I'm sorry, the Texas Instruments. So we're going to come over here and we're going to go to Stat, go to Tests. If I click up once, it'll take me to the end, and I want to run this ln-reg t interval. Let me do the Texas Instruments 84 first, because that tends to take a little bit of time. So this is a custom program I made. So hit the Programs button, go down to Linear Regression T Interval 83. Okay, our values are in list 1. Our Y values are in list 2. We have a confidence level of 0.975. Hit enter. Okay, while we're waiting on that one, we'll come back to this one. Okay, list 1, list 2, that's good. Confidence level is 0.975. Go down and hit calculate. And you can see here we have negative 0.0499 and a positive 9.7047. And if we come back here, okay, the TI-83, which is an older model. There we go. So you can see we also get a negative 0.0499 if we rounded it, and a positive 9.7047 if we rounded it. So we come to the same answer down here. Okay, that is it. That's an extra page I think we don't need. All right, so we answered, all 4 questions in a little over a page. All right. Let me know if you have any questions.